Let's build a classification app using LLMs. And in this example, we are going to have a couple of product reviews, like this product is good, the product is not so good, this product is okay, etc. And we are going to analyze the sentiment of each one of these reviews. So this function will be called for each one of these reviews, and it will return something like positive if the review is positive, or negative if it's negative, and so on. And to implement that, we are going to use LLMs. So the first step is really to construct a prompt, is to do some string formatting. So let's do that. And we can start from something basic, like analyze the sentiment of the following product review. Oh, sorry. And then the product review. And then we want to instruct the LLM to respond with positive, negative, or neutral. And now essentially we need to call an LLM with this prompt. So we are just going to do something really basic here and call the OpenAI API. And essentially we need to create a chat completion object. So this is how it looks like, client.chat.completions.create. And we can, the first parameter is to choose which model we want to use. So in this case, we are just going to go with GPT 3.5. And we need to pass an array of messages. So this represents the entire chat history. But in this example, we have only one message, which is our prompt, and it comes from the user. So we can just do something like this. Role is user, and content is the string formatted prompt. So let's start by storing this in some variable and just printing it just to see how it looks like. And we can essentially iterate each one of these product reviews and call the analyze sentiment function. So for review in product reviews, then we can call the analyze sentiment. So let's open a terminal here and run this file. OK, so for each one of our product reviews, we see a chat completion object. And this object contains the response. So you can see here positive and negative and neutral. So let's actually make sure to remove all of this boilerplate and just return the response. So this is response.choices, the first choice. Obviously, by default, we only return one response. So this is this index here. Message content. And let's make sure to return this from our function. And we can print it right here. So let's run this again. OK, so we see that the sentiment makes sense. So we have this is positive, this is negative, and this is neutral. But as you can see, this is not really consistent. So each time we get a little bit different response. So this is a full sentence. This is a single word. Here the N is uppercase, and here it's lowercase. And this is really hard for us to parse. And we really want to make sure that, that the results are consistent and they contain just one single word. So in order to accomplish that, there are a couple of tricks that we can do. First of all, let's start by some prompt engineering. So instead of just responding like this, let's instruct it to respond only with positive, negative, or neutral. And quoting here helps a lot. Another thing that we want to do is to change the role to system. So this is a system prompt, not a user prompt. And there are a couple of parameters that we can pass here that really helps the LLM be more consistent. So those are seed and temperature and top P. So if we run this again, this should be much more consistent. And a really good way to actually evaluate that. So let's, for example, let's revert our changes real quick. So let's get back to exactly the way it was. And what we can do, instead of analyzing each one of these reviews, let's analyze only a single review. OK, so I'm just going to comment this and just pass the first review. And instead of generating only one response for this review, let's generate 20 responses for this review. And let's just iterate each one of these responses. So for choice in response.choices, and let's print it. And this will really help us see if the LLM is consistent or not. So right here, for this review only, we can see that we get so many different responses, like positive and yeah, so many different responses. But if we add the parameters from before, so let's make this only and quote, and it should be a system prompt, and let's pass the temperature and top P and seed. Now we will see that it looks much more consistent, right? And we can try this for a different review, and it looks much better. So let's continue to analyze all of our reviews and remove this trick here. So we want to generate only one response. So so far, our code is pretty simple. We just have a bunch of reviews. We analyze them. We make the response consistent, and we analyze the sentiment. Cool. So one really good thing that we can do is to actually add explanations. So instruct the LLM to explain why this review was positive, why it was negative, and so on. So this is good in two fronts. So first of all, this improves the model accuracy because it kind of have time to think. And also it's good for user experience because the user can understand, okay, why is this review positive and why is it negative? So the way we are going to do that is by returning a JSON format. So right now we don't want to return only the sentiment, but we also want to return the explanation for the sentiment. So instead of responding only with the sentiment here, we want to actually respond with JSON that has two keys, explanation and sentiment, where sentiment can only be each one of our possible values. And there's a really nice trick that you can actually do here to enforce the LLM to respond with valid JSON. And we can add this parameter here. We just make it a valid JSON. And for that, we will need a newer model. I think this is the one. Hope I'm right. So let's run our code again. Okay, so for each one of our reviews, we now get the explanation and the sentiment. And it's actually really important to make sure that the explanation comes before the sentiment. This improves the model accuracy. But as you can see, actually, we didn't force the response to have a certain schema. We just instructed it in the prompt to respond with explanation and sentiment. But it's actually much better to provide a specific schema of the JSON that we want to analyze. And to do that, we will need to make some changes to our code. And there is a really cool feature called function calling, which allows us to really constrain the way that the LLM responds. So instead of just returning a JSON here, we are just going to pass a tool to the LLM. And this tool is called report sentiment. And essentially, it's a function that the LLM can call. And it will report the analyzed sentiment with the explanation for it. And we will pass here two properties to the JSON object here. So we have explanation and we have sentiment, really similar to what we have here, but now it's actually enforced. And one cool trick that you can do is that sentiment can be an enum. So it can only be one of those values which are required. So now actually we don't need this instruction. The response won't actually return like this. It will return us the arguments to this function. And we can extract this using something like this. Let's just run this and see how it looks like. Okay, so inside the tool call object, we have function and then arguments. So let's just do this. Now it's really similar, but essentially now the schema of this is enforced. Great, so now we can actually store the results in some CSV file that we can easily analyze. So instead of just printing, let's actually do this. Let's actually construct an array of objects here. And instead of just having the sentiment itself, we also want to add the original review. This includes the explanation and the sentiment. And let's actually store another field just for the actual. So, if sometime later we have the real value for the sentiment, so maybe a human actually goes through the different reviews and actually sees this is positive, this is negative, they will be able to edit the CSV and we can actually measure and evaluate the LLM accuracy. So this is our data. So import pandas. And then we can initialize a data frame and save it to a CSV file. So let's open the files here and run this again. Oh, so actually this by default returns a string. We need to convert this to a JSON. So let's import JSON and just parse the results here. And let's run this again. Okay, great. So now we have this CSV file. Let's open it in a more convenient way. Okay, so we have the review. We have the sentiment, and we also have the explanation for the sentiment. So let's actually, kind of classify this. So maybe this was true, and this was not true, and maybe this was true, and this was not true. And now we can essentially evaluate the LLM performance. Obviously, this might not be real, but just for demo purposes. So let's create a file here called evaluate.py. And we can import pandas here and read our CSV file. So just read data CSV, we can store it. This is a data frame. And what we need to do is essentially we can use a library such as sklearn. I think there are a couple of metrics here. Yeah. So accuracy score essentially allows us to compare the actual and the sentiment and see our accuracy in percentage. So let's just call accuracy score. And the first parameter is the true values. This is the actual column. So we can just do something like this. and the second parameter is our prediction, is the LLM prediction. So this would be the sentiment, right? So this is y true, and this is y pred. And this should return the accuracy score, and we can just print it. So let's see. Okay, so this is our current accuracy, but if we would to change this to be all equals and run it again, so essentially we get 100%, and this means that it's perfectly accurate. And this way you can actually evaluate your model and improve the different parameters and the prompt.